Today's lesson is Chapter 2, Lesson 1, called Rational Numbers. So let's start off with some vocabulary. First thing, if we're going to talk about rational numbers, we ought to know what a rational number is. So let's get a definition down. A rational number is any number that can be written as a fraction that has a whole number in the numerator and in the denominator. And we will look at a couple of examples in just a moment. So let's take a look at this diagram in the top of your page here in the center about rational numbers. You'll see that rational numbers is a large set of numbers that includes integers and whole numbers and some other numbers. We've already talked about whole numbers and integers, and now we'll talk about what rational numbers are. So again, let's take some examples. Any number that can be written as a fraction that has a whole number in the numerator and in the denominator. So for example, 1/2. If we look at 1/2, number 1 is a whole number in the numerator. If we look at the number 2, it is also a whole number in the denominator. So that would be a rational number because it can be written with a whole number in the numerator and in the denominator. But how about the number 5? Doesn't look like it has a numerator and a denominator, but we can rewrite this. We can rewrite this as 5/1. And the 5 and the 1 are both whole numbers. The 5 in the numerator, the 1 in the denominator. And lastly, we have a number like 1.2. Well, we can rewrite this as 1 2/10. And the 2 is a whole number in the numerator, and the 10 is a whole number in the denominator. So that is also a rational number. Another way we can check to see if a rational number is in fact rational is by turning it into a decimal and then looking at the decimal and seeing if it has two certain qualities or one of two certain qualities. The first being if it's a terminating decimal. So if we take something like 1/2 and change it into a decimal, it would be 0.5. A rational number is a number that if we turn it into a decimal, it will either terminate like 1/2 did here, 0.5, which means the decimal comes to an end. All right. The other thing that a rational number could do, if it doesn't terminate, it could repeat. So let's take the fraction 1/3. If I turn that into a decimal, it's 0.3, and the 3 repeats forever. So a rational number could be one that if we turn into a decimal, it will terminate or end, or the key word is or, it doesn't have to do both, just or, it could also repeat. So what it does is it never ends, and it has a repeating pattern. And we've talked about these types of decimals before, but we're just reviewing that as it pertains to rational numbers. Okay, so there we go. That's what a rational number is and how we can see if a number is rational. We can either look at the fraction and determine are there whole numbers in the numerator and denominator, or we can turn the number into a decimal and the decimal will either end or it will repeat. So now we're going to do some work with these rational numbers. So in example 1, we're going to be writing rational numbers as decimals. So in example A here, we're going to be taking -2 1/4 and turning it into a decimal. So the first thing that we need to do with this is anything that's in front of the fraction. So we have this -2 portion in the front, right? We're just going to carry that forward as part of our answer. We're going to keep our whole number and sign the same. Okay, if it doesn't have a whole number, we wouldn't write one there, but this one does. So we're going to keep it with the sign. We're going to add a decimal point, and now we got to figure out what is the rest of this going to be. So what we need to do is we need to take this 1/4 that we have remaining up above, and we're going to use long division to turn that into a decimal. Hopefully you remember how to do that. Now, 1/4, when we look at this, the numerator always goes inside the division house. So we put the 1 on the inside. The denominator always goes outside the division house. Now, for long division, we check to see, does the 4 go into the 1? No, it goes 0 times, so we put a 0 there. We add a decimal point, and we bring the decimal point up top. We add a 0. And now we can say, does 4 go into 10? And yes, it does. It goes in twice. 2 times 4 is equal to 8. We subtract the 8 from the 10. We get a remainder of 2. We add a 0 to the 1 and the 0 that are already there, and we bring it down. And we have 4. Does it go into 20? And 4 goes into 20 exactly 5 times. So now that's equal to 20, and we have a 0 remainder, so we are finished. So we're going to take this 0.25 portion of it, and we're going to bring it over and add it to what we've already written. The 0 added to 2 is still just -2, and the 0.25 part we're going to write in as our decimal portion. So -2 1/4 is equal to -2.25. All right, let's try another example over here. Write 5/11ths as a decimal. There is no negative sign or no whole number that we're going to bring down and include in our answer, so we're just going to do the fraction portion. So again, the 5's in the numerator, so the 5 has to go inside the house, and the 11 in the denominator goes outside. The 5 is being divided by the 11. So 11, does it go into 5? 0 times. Add a decimal and bring it up to the top. Add a 0 to our 5. Does 11 go into 50? It does. It goes in 4 times. 4 times 11 is 44. So we subtract the 44 from 50, and that's a remainder of 6. Add another 0 and bring it down. Does 11 go into 60? It does. It goes in 5 times, and that's 55. That has a remainder of 5. Another 0 is added and brought down, and we have 50. 11 goes into 50 4 times, and that's 44. And I've realized now that I started to repeat what I was doing earlier in the problem. I have a remainder of 6. And as a matter of fact, when I got the 5 as a remainder in the step 4, that's the same as the 5 that we started with in the beginning. So now I have to look and say, okay, at what point did the repeat start? It started right here at this 5. All right, so when I go from that 5 and go up to the top, I notice that I have 0.45 and then another 4. So the 4 and the 5 are going to repeat. So I'm going to write my answer as 0.45. Let's make that decimal a little bigger so we can see it. And the 4 and the 5 are now going to repeat. So we'll put the repeating sign above the 4 and the 5 to complete the answer to that problem. There's a couple down here that we're going to do a couple more together. And then you guys will do some on your own at the end of the lesson. So we have -3/11ths. So the first thing I notice is there's a negative sign, so I'm going to carry the negative sign down to my answer. There is no whole number, so I'm just going to use the fraction. The 3 in the numerator goes inside the division house, and the 11 goes outside. 11 goes into 3 0 times, decimal point, bring it up, add a 0. 11 goes into 30 twice. That's 22. Subtract that 22 from the 30, and I'm left with a remainder of 8. Add another 0 and bring it down. 11 goes into 80 7 times. 7 times 11 is 77. And that's a remainder of 3. And I notice that this remainder of 3 is what I started with in the beginning. So the 2 and the 7 are now going to repeat. So my answer is going to be 0.27 with the repeating bar above it because it repeats. Last example of converting rational numbers into decimals. I have -7 3/8. I see that there's a negative and a whole number, so I'm going to carry those down to my answer, -7. And now the fraction is 3/8, so I'm going to go ahead and do long division on that. The 3 goes inside the division house, and the 8 goes on the outside. 8 does not go into 3, so there's a 0. Decimal point, bring it up, add a 0. 8 goes into 30, excuse me, 3 times. 3 times 8 is 24. Subtract 24 from 30, we get a remainder of 6. Add a 0 and bring it down. We have 60. 8 goes into 60 7 times. 7 times 8 is 56. That gives us a remainder of 4. Add another 0 and bring it down. And now we have 8 into 40. 8 goes into 40 exactly 5 times. Okay, so we have to take this 0.375 that we have right here and add it to what we already have with the -7 that we carried down from the beginning of the problem. So it's going to equal -7.375. All right, and that's how we're going to change rational numbers into decimals. We're going to use long division in order to do that, and we're going to carry down any negative signs in whole numbers straight down to our answer. Okay, now we're going to go to example 2, where we're going to write a decimal as a fraction. So we have a few examples here to do. So we're going to write -0.26 as a fraction in simplest form. Please don't forget, we got to simplify this. So here's what we need to do. We have to see if we have any whole numbers that we're going to carry down. No whole numbers. I got a 0, so we're not going to carry that. But what I am going to do is I'm going to carry that negative sign. So I'm going to keep that negative sign in my answer. So I got to make sure I have a negative sign for my answer. Now I have 0.26. I need to look at the number furthest to the right of the decimal, in this case, which is the 6, and I have to figure out what place value is that on our number lines. So the 0 is in the ones place, the 2 is in the tenths place, that's with the THS at the end, and the 6 is in the hundredths place. The reason I need to know that it's in the hundredths is because it's going to tell me what my denominator of the fraction will be. My denominator is going to be based on the place value, and since it's the hundredths, I'm going to put my denominator as 100. Now all I have to do is take the number that's to the right of the decimal, the entire number, all the numbers there, and write them in my numerator. So I have 2 and 6 to the right of the decimal, so I'm going to write them in my numerator. So I have -26 over 100, or -26 100ths. And all I have left to do now is to simplify this. And if I divide the top and the bottom by 2, I will get -13 50ths. So I want to make sure I divide the top and the bottom by 2. And that gives me -13 over 50. Next example is write -3.1 as a fraction in simplest form. So again, I'm looking for any negative signs in whole numbers, and I have both. So I want to make sure that I keep both of those in my final answer. So I get a negative and a 3. And now all I have to do is change this 0.1 into a fraction. So again, I identify what's my number furthest to the right of the decimal. Well, it's only the 1, and the 1 is in the tenths place. Okay, so the tenths is going to give me my denominator. So I'm going to put that in the denominator. Tenths gives me a 10 in the bottom, in the denominator. And now all I have to do is write any numbers that I have to the right of the decimal point in my numerator, and it would just be a 1. And I look at that 1/10 and see if I can simplify it, and I can't. So my final answer would just be -3 1/10. Okay, so let's do a couple more examples of this. I have 0.125. I don't have a negative sign or a whole number that I'm going to keep in my answer. So my answer is just going to be a fraction. So I need to figure out my denominator. So I'm going to look at the number furthest to the right. It's a 5. The 1 is in the tenths place. The 2 is in the hundredths place. The 5 is in the thousandths place. So I'm going to use that thousandths to give me my denominator, which would be 1,000. And then I'm going to write any numbers to the right of the decimal point in the numerator. So I have 125 over 1,000. And I still need to simplify this. Well, I know that the top and the bottom, the numerator and the denominator, can be divided by 25. So if I divide the top by 25, I'll get 5. If I divide the bottom by 25, let me take a look at that. I think that's going to be 40, but I'm going to double check. 40 times 25. 5 times 0 is 0. 5 times 4 is 20. 2 times 0 is 0. I need a 0 here for a placeholder. And 2 times 4 is 8. And so that gives me 1,000 when I add that together. So that would be right. So I have 5 over 40. But when I look at that, I see that I can still divide the top and the bottom by 5. So I'm going to go even further. 5 divided by 5 is 1. And 40 divided by 5 is 8. So my final answer would be 1/8. Number 2, you'll see, is the same as it was above. So I want to change this problem. We're going to change this to a negative 4.75. So again, I look and see, do I have any negative signs or whole numbers? I do. So I want to make sure that I keep them as part of my answer. All right. So then all I have left to do is the 0.75 and turn that into a fraction. So I look at this and I say, okay, the number furthest to the right is the 5. The 7 is in the tenths place. The 5 is in the hundredths place. So what I need to do is, for my fraction, I need to make sure I have 100 in the denominator. And I'm going to take any numbers I have to the right of the decimal and put them in my numerator. So I have 75 over 100. Now I have to check and see if I can simplify. Negative 4 comes down, and I know that the 75 and the 100 are divisible by 25. So 75 divided by 25 is 3. 100 divided by 25 is 4. And now I cannot simplify it any further. So my final answer is negative 4 3/4.
Mr. Charles, could you come to the office, please? Charles, come to the office.
All right. Okay, our last portion of today's lesson is ordering rational numbers. And the goal here is to be able to order rational numbers using a number line. In order to do so, we're going to need to take these 4 numbers and turn them into all the same form, whether it be all fractions or all decimals. My opinion is that changing them into decimals is the easiest way to go. Especially at some point you'll be able to use calculators to do this. For today's example, I'm not going to worry about calculators. I'm just going to do it with long division. So I'm going to change the first one, negative 13 tenths, into decimal. So I know my answer is going to be negative, so I'm going to carry that negative sign over. And I'm going to do the division. I know that the numerator goes inside the house. So let's do it over here. So the 13 goes in the house and the 10 goes outside the house. How many times does 10 go into 13? It goes in once, and that would be 10. 13 minus 10 gives me 3. All right, I have to add a decimal point and bring it up. And 10 doesn't go into that 3, so I'm going to add a 0 and bring it down. And how many times does 10 go into 30? It goes in 3 times. That's exactly 30. So I don't have a remainder, so I'm finished. So my final answer, I have this negative sign that I have to remember to keep. So I'm going to bring that over here, negative, and then my answer to our long division problem was 1.3. So negative 13 tenths is equal to negative 1.3. I'm going to erase this so I can do the other ones that are here. Oops, didn't mean to erase all that, but let's get rid of the whole thing. So this is equal to negative 1.3. All right, so let's do the next one. We have negative 2 1/5. All right, well, the negative and the 2 we know we're going to keep in the answer. So let's just put those right there. All right, and we need to change the 1/5 into a decimal. So the 1 goes inside the house. The 5 goes outside. 5 goes into 1 0 times. Add a decimal, bring it up, add a 0. 5 goes into 10 exactly 2 times. 2 times 5 is 10. When we subtract, we get a remainder of 0. So the decimal portion of my answer here is going to be 0.2. So we have negative 2 1/5 is equal to negative 2.2. Let's erase this, and we can do the next one. So we have negative 2 11ths. The only thing I can carry to my answer is a negative sign. And then I'm going to do long division. So I have 2 divided by 11, so the 2 goes inside the house. The 11 goes outside the division house. 11 goes into 2 0 times. Let's put a decimal and bring it up. Add a 0. 11 goes into 20 just once. 11 times 1 is 11. We do the subtraction, we get 9. 11 doesn't go into the 9, so we add another 0 and bring it down. 11 goes into 90 8 times, and that's 88. And we have a remainder of 2. I notice that my remainder is what I started with in the beginning, so I'm going to end up having a repeating situation. So I'm going to have a repeating bar over my 1 and my 8. So I have a negative 0.18, and the 1/8 is going to repeat. And then lastly, my last one for the whale is already in decimal form. So I'm going to just keep it as negative 0.8. So in order to compare these, what we need to do is we need to make a number line so that we can put these numbers on the number line and see which one is least, which one is greatest, and where the other two are in between. So let's take a look at what our number line should look like. We should have a 0 somewhere in the middle. I know I have a negative 1 to the left, a negative 2 to the left, and maybe a negative 3 out here to the left. And to the right, I have a positive 1, a positive 2, and we can go up to positive 3. Because my numbers don't really go that far in either direction that I'm looking at right here. So I have to figure out first, where is negative 1.3? If I start at 0, negative 1.3 means to go 1.3 units to the left. So that means I'm going to go to the left 1.3 units. Well, I just passed the 1, and the 1.3 is going to be a little bit past that. So I'm going to put a point right there and say that's negative 1.3. Okay, and I went to the left with that. The next one's negative 2.2. So I got to start at 0, and I'm going to go to the left again because it's negative 2.2 units. I'm going to pass the negative 2, and I'm going to go just a little bit past that, and that's about where my negative 2.2 is going to be. So that one's negative 2.2. Then I have negative 0.18. So I'm going to go down below here. Well, if I go from 0, I'm going to the left 0.18 units because it's negative. And it's repeating, but we're not going to look at that right now. We're just going to go negative 0.18, or where we think that's going to be. Well, negative 0.18 is pretty close to negative 0.2, which is only a little bit to the left of 0. So I'm only going to go a little bit to the left of 0, and I'm going to be at about negative 0.18, and that's a repeating. And then lastly, I have negative 0.8, which isn't quite all the way to, starting at the 0, I'm going to go 0.8 to the left. And 0.8 to the left doesn't quite get me to the whole number of negative 1, or the integer, I should say, of negative 1. Not quite to negative 1. It's a little bit less than negative 1. So we're going to put in a point there. Let's draw an arrow to this. This is negative 0.8. Okay? Negative 0.8. So now we have our 4 numbers listed on the number line, and we're going to be able to identify which one is the least, because the one that's the least is furthest to the left. The one that's the greatest is furthest to the right on the number line, and then the 2 numbers that are in between fall somewhere between least and greatest, and we just have to do it in order. So the number that's furthest to the left would be negative 2.2. The next number furthest to the left would be negative 1.3, so that's the next smallest number. The next number further to the left would be negative 0.8, which is, oops, I'm sorry, that's supposed to be an 8 there. Negative 0.8. And then finally, our greatest number is negative 0.18, repeating. Now, you'll notice that our answers that we just wrote down here don't match with what we started with here in the problem. So what we have to do is we have to take these numbers in decimal form and rewrite them in their original form. If it was originally as a decimal, then we'll leave it as a decimal. But anything that was originally a fraction, we got to change back into a fraction. So negative 2.2 started as negative 2 1/5, so I need to write that in my final answer. Negative 1.3 started as negative 13/10, so I want to rewrite it as negative 13/10. Negative 0.8 started as negative 0.8, so I'm going to leave it that way. And then negative 0.18 repeating started as negative 2/11, so I'm going to rewrite it as negative 2/11. And now we have our final answer. The smallest number is negative 2 1/5. The next smallest is negative 13/10. The next smallest is negative 0.8. And our largest number is negative 2/11. And that's how we order rational numbers on a number line. Again, remember, we need to convert all the numbers into the same form, whether we change them all into fractions or all into decimals. Once we do that, we can then place them on a number line. And I think placing them as decimals on a number line is the easiest way to do it. And then we can convert them back to the original form once we get them lined up in order. All right, let's take a look at this last problem here. And then, excuse me, you'll have some problems that you'll have to do on your own and turn into your teacher if in fact you were absent and this is in order to make up what you missed. So the elevation of a dolphin is negative 1/10 kilometer. Which of the sea creatures in example 3 are deeper than the dolphin? And explain. So we got to go back up to our original problem and look at these creatures up here and see which ones are deeper. So what I think we ought to do here is we ought to take a look at negative 1/10 and convert that into a decimal. So negative 1/10. We're going to keep the negative sign. And then all we're going to do is turn the 1/10 fraction into a decimal. So the 1 goes in the house. The 10 goes outside the house. 10 goes into 1 0 times. Add a decimal point, bring it up. Add another 0. 10 goes into 10 exactly 1 time. So our answer is going to be the negative that we brought over and the 0.1. So negative 0.1. Now, if we go back up to our number line that we had up there already and place this point on there, it'll tell us which other creatures are deeper than our, I don't know what our dolphin in this example. No, I'm sorry. Yeah, this dolphin. Okay. So we have negative 0.1. So if we start at 0, that means we're going to go 0.1 to the left. And 0.1 to the left is very close to 0. And not as far as the negative 0.18. Negative 0.18 is smaller, further to the left than negative 0.1. So that one's going to go somewhere in about here. And this would be negative 0.1. Okay? Now, if I really wanted to compare, if I had negative 0.18 and negative 0.1, the really only way I can compare these, because they have they have a different number of numbers to the right of the decimal point. Negative 0.18 has 2 numbers to the right. The 8 is in the hundredths place. Negative 0.1 only has a 1 to the right. That's in the tenths place. I need to be able to compare decimals that have the same number of decimal places. So what I'm going to do for the negative 0.1, I want to add a 0 to the right of it so that now the 8, which is in the hundredths place, and the 0 is in the hundredths place. Now we can accurately compare 18 100ths and 10 100ths. But since it's negative, that means 18 100ths is negative 18 100ths is further to the left from 0 than negative 10 hundredths. 18 hundredths is further away from 0 than 10 100ths is. And since it's in the negative direction, it's to the left. And that's why our point up here where negative 0.1 is to the right of negative 0.18 because it's actually larger than negative 0.18. So we have to make sure that we have the same number of decimal places here and here to make an accurate comparison. So when we go back to the question, it says the elevation of a dolphin is negative 1/10 kilometer. Which of the sea creatures in example 3 are deeper than the dolphin? Explain. Well, that means all of them are going to be deeper than the dolphin because the more negative something is, the deeper it is. If we were to turn our number line like this and had 0 here, you'll see that the further down we go, the deeper we are. And that's kind of like the further left we are on the number line. The further down is more negative. So the more negative things, the deeper it would be. Okay? So that's why all of those sea creatures are deeper, because they're all more negative than our dolphin, which is sitting at negative 0.1 or negative 0.110. All right, so they're all deeper than the dolphin. All right, so that is the end of lesson 2.1. If you have any questions on this lesson, be sure to ask Mr. Billemeyer or Miss O'Hagan when you come to school. On the next page, there are some problems that if you are watching this at home due to an absence, you need to complete the following exercises and turn them into your teacher. And we do expect to see work for these problems. So make sure that you have the work and the correct answers and turn them into your teacher so that you can get credit for completing the lesson.